Welcome everyone. Through this video, today I will discuss about an important topics of determinant and matrix. Solution of linear simultaneous equation by matrix method or determinant method. That is consistency and inconsistency of system of linear equation. So before we start, we see the theory. So let us consider the equation a1x, a2x, b2y, c2z equals to d2 and a3x, b3y, c3z equals to d3. So linear simultaneous equation. Three unknown, three equations. So above equation can be put in matrix form as capital X equals to B, where A equals to coefficient matrix. So A1, B1, C1, A2, B2, C2, A3, B3, C3. X equals to column matrix X, Y, Z, and B equals to D1, D2, D3. Now, if determinant A not equals to 0, then A inverse exists. And X equals to, we know, A inverse into B. Solution is unique. Solution is unique. This part is included to our board syllabus in both CBSE, CBSE and West Bengal board. Now, if determinant A equals to 0, then there are two possibilities. Then we calculate adjoint of A into B. If it is 0, then infinitely many solutions. We calculate adjoint of A into B. If determinant A equals to 0 and adjoint of A into B not equals to 0, then no solution. No solution. So right hand side is non-zero, so this is non-homogeneous linear simultaneous equation. So for unique solution, determinant A not equals to 0. If determinant A equals to 0, then there are two possibilities. Adjoint of B equals to 0, infinitely many solution, and adjoint of A into B not equals to 0, no solution. So if system of equation has solution, unique solution or infinitely many solution, then they are said to be consistent. If no solution, inconsistent. Now to find adjoint of A, it is lengthy. So to solve this type of equation, we use determinant method. So if determinant A not equals to 0, so determinant A not equals to 0, then system of equation has unique solution. Unique solution. So what is x? X equals to delta 1 by a, determinant a. Y equals to delta 2 by determinant a. Z equals to delta 3 by determinant a. Or we can write determinant a as d. This method is called Cramer's rule. Cramer's rule. If determinant a equals to 0, same case, if determinant a equals to 0, then we calculate delta 1, delta 2, delta 3. If determinant a equals to 0, we calculate delta 1, delta 2, delta 3. If delta 1 equals to delta 2 equals to delta 3 equals to 0, then infinitely many solutions. Infinitely many solutions. And if any one of delta I not equals to 0, no solution. Now what is delta 1? You know what is delta 1? Delta 1 is a determinant. What is delta 1? Delta 1 is a determinant obtained by replacing A is first column by d1, d2, d3. So d1, d2, d3, b1, d2, d3, c1, c2, c3. Similarly, delta 2. So this is d1, d2, d3 and a1, a2, a3, c1, c2, c3. And delta 3 is d1, d2, d3. What is delta 3? So this one is d1, d2, d3. a1, a2, a3, b1, b2, b3. This is delta 3. So listen again. What is Cramer's rule? Coefficient, so determinant delta A, here A, this determinant, if we change matrix to determinant, so if it is not equals to 0, then unique solution. Similar like this. And we get x, y, z by this rule. This is called Cramer's rule. If determinant A equals to 0, then there are two possibilities. Delta 1, delta 2, delta 3, all are 0. Infinitely many solutions. If any one of delta I not equals to 0, no solution. So we prefer using determinant because adjoint of B, to calculate adjoint of B, it is lengthy. Now, what is infinitely many solutions and no solutions? So, let us consider an example. So, look, in 2 dimensions, this is, suppose x plus y equals to 2 and 2x plus 2y equals to 4. Actually, they represents coincident line, a1 by a2, b1 by b2, c1 by c2. So, infinitely many solutions. So, coincident line, infinitely many solutions. In this case, we get delta 1 equals to delta 2 equals to 0. Delta obviously 0. And now, if x plus y equals to 2 and x plus y equals to 4, then they represent parallel line, no solutions, no solution. Here adjoint of A into B not equals to 0, or delta 1. What is delta 1? You look, delta 1, 2, 4, 1, 1. So minus 2 not equals to 0. That is why no solutions. Now, second part. If this is 0, this one is 0, then they are called homogeneous equation. Homogeneous. Then Ax equals to 0 equals to null matrix. So in this case, look, delta 1, first row is 0, 0, 0. So this is 0. Delta 2 equals to 0 and delta 3 equals to 0 because one row is 0. So in this case, delta 1 equals to 0, delta 2 equals to 0, delta 3 equals to 0. If delta equals to determinant, coefficient matrix A1, A2, A3, B1, B2, B3, C1, C2, C3. If delta not equals to 0, then by Krammer's rule, x equals to delta 1 by delta equals to 0. Delta 2 by delta equals to 0. Delta 3 by delta equals to 0. So, for homogeneous equation, if delta not equals to 0, we get x0, y0, z0. Unique, this is called unique, 0 solution. 0, it is called also trivial solution. And if delta equals to 0, then adjoint of A into B equals to 0. Or here delta 1, delta 2 in terms of determinant 0. So infinitely many solutions. Many solutions. So for homogeneous equation, right hand side 0, unique solution. When delta not equals to 0, infinitely many solutions. When delta equals to 0. So this is our working tool. You get at least 1 marks in JEE Main. So we consider some problem now. Now we solve some problem using this theory. So problem number 1. Let S be the set of distinct values of B for which system of equation has no solution. Then what is S? S is infinite set, finite set, singleton set, empty set. So what is S? S be the set of values of B. So that is, you have to find set of how many values of B. So no solution. So we calculate delta. If delta equals to 0, then there are two possibilities. No solution, infinitely many solutions. So 1, 1, 1, 1, A, 1, A, B, 1. So if we expand it, A in 1 into A minus B minus 1 into 1 minus A 1 into 1 minus A plus 1 into B minus A square B minus A square B minus A square. So A minus B minus 1 plus A plus B minus A square. So B cancel out. So 2a minus common a square minus 2a plus 1. So a minus 1 whole square. So necessary condition, that is delta equals to 0. If delta equals to 0, then a equals to 1. So if a equals to 1, then there are two possibilities. Determinant delta, so infinitely solutions or many solutions. So if we get a equals to 1, so what we are getting? X plus y plus z equals to 1. X plus y plus z equals to 1. So x plus by plus z equals to 0. Now they represent same equations. So if b equals to 1, look, if b equals to 1, then if b equals to 1, then there are no solution, because these two equations same and they are parallel planes. So if b equals to 1, then no solution, because in this case we are getting equations like this: x plus y plus z equals to 0. So we are getting no solution. So for b, for no solution, so what is condition on b? B equals to 1. So number of values of b, how many values of b we are getting? That is 1. Therefore the b equals to only one member. So S has only one member, that is singleton set. So we calculate delta. Delta equals to a minus 1 whole square. If a not equals to 1, then unique solution. So this case is not possible. So if a equals to 1, so equation reduces to this. These two equations are same. And if b equals to 1, so they represent parallel planes. So no solution for b equals to 1. So this is problem of JEE main. JEE main. Now problem number 2. So this is also non-homogeneous equation. Non-homogeneous equation. The system had unique solution, infinitely many solution, no solution, finite number of solution. So we calculate delta. So what is delta? That is coefficient. Determinant 1, 4 minus 3. 1 minus 1, 7. 2, 8 minus 6. So if we calculate 1, 6 minus 56 minus 4 into minus 6 minus 14, no, minus 6, 6, 4, so minus 1, 6 minus 14, 6 minus, minus 6 minus 14, minus 3 into 8 plus 2, 8 plus 2, so minus 50 plus 80, and this is minus 30 equals to 0. So unique solution is not possible. Unique solution is not possible. So delta we have calculated. Now there are two possibilities: infinitely many solutions or No solutions. So what is delta 1? Delta 1, 3, 11, 7. So 4 minus 1, 8. Minus 3, 7, minus 6. So we can calculate adjoint of A into B or this one. So use determinant. So 3, 11, 7. So if we expand 3 into 6 minus 56 minus 4 into 4 into minus 66 minus 49 minus 3 into 88 plus 7. 88 plus 7. So minus 150. Minus 150. This is plus 66, 49. So if you add 5, 115 into 4. So 460. And this is 88, 95 into 3. So 285. So this is minus 285. So this is not equals to 0. So if any one of delta I not equals to 0, no solutions. So C is possible option. Now we consider two homogeneous equations. That is, right hand side is 0. So problem number 4. The linear equation, this has one solution, finite number of solution, infinite number of solution, none. So this is very simple problem. So one solution, that is delta non-zero. And if delta equals to 0, then infinitely many solutions. So we calculate delta. So 8 minus 3 minus 5. So 5 minus 8, 3. So they are all problem of JEE main. So 3, 5 minus 8. This is delta. So if you simplify 8 into 64 minus 15 plus 3 into minus 40 minus 9 minus 40 minus 9 minus 5 into 25 plus 24. So 8 into 5, 45 minus 3 into 49 minus 5 into 49. So 8 into 45, 3 to 0, 3 to 0 and 40, so 360 minus 49 common, 3 plus 49 common, 3 plus 5, 3 plus 5, 49 common, 3 plus 5. So this is 8. So let us verify again. 8 minus 3 minus 5. 5, 8, 3. 3, 5. 3, 5 minus 8. So 8 into 64 minus 15. So 45. 5. So 64 minus. This is wrong. This is 49. This is 49. 49. So 49 common. So 8 minus 3 minus 5 equals to 0. So this is 49. So very simple problem. We calculate delta. Delta equals to 0. So infinitely many solutions. It is homogeneous equations. Now problem number 7. Exactly same theory. So look, this is x1 and right hand side also x1. If we transfer all term to left hand side, then this is homogeneous equations. So x1 common, 2 minus lambda minus 2x2 plus x3 equals to 0. 2x1 minus x2 common, 3 minus lambda 2x3 equals to 0. Then minus x1 plus 2x2 minus lambda x3 equals to 0. So this is homogeneous equation. Has non-trivial solution. For non-trivial solution, we know delta not equals to 0. So therefore, delta not equals to 0. Delta equals to 0. Non-trivial solution has non-trivial solution. Delta equals to 0. So non-zero solution. So determinant 2 minus lambda minus 2, 1. 2, this is minus, so lambda minus 3. This is 2. This is minus 1, 2 minus lambda equals to 0. Now we have to expand it. So 2 minus lambda into lambda square minus lambda square plus 3 lambda minus 4. This into this. Lambda square minus lambda square plus 3 lambda minus 4. So plus 2 into, this is minus, so plus 2 into minus 2 lambda plus 2 minus 2 lambda plus 2 plus 1 into 4 plus lambda minus 3 equals to 0. So 2 minus lambda into minus lambda square plus 3 lambda minus 4 lambda plus 4 minus 4 lambda plus 4 plus 4 minus lambda minus 3 equals to 0. So again we have to multiply it. Minus 2 lambda square plus 6 lambda minus 8 plus lambda cube minus 3 lambda square plus 4 lambda minus 4 lambda plus 8 minus 3 minus 4 lambda plus 5 minus lambda equals to 0. So 4 lambda cancel out. So lambda cube minus 2 lambda square minus 3 lambda square. So minus 5 lambda square plus 6 lambda minus lambda. So 5 lambda. 6 lambda, 5 lambda. Then this is minus 8 and minus 8 and this is 4 plus 4, 8 minus 3. This is 5. So minus 3 equals to 0. So this is cubic equation. So cubic equation, if we put lambda equals to 1, so 1 plus 5, this is 6, 5 minus 3. So listen again. I think 2x1 minus, so this is x2 common, this is 3 plus lambda. This is, if you transfer this to left hand side, 3 plus lambda. So minus 1 plus 2 minus lambda. So this will be lambda plus 3. Lambda plus 3. So 2 minus lambda. So we have to 2 minus lambda. Minus lambda square. Minus 3 lambda. 2 minus lambda plus 3. 2. Lambda plus 3 within bracket. Minus 2, 2 minus lambda. So we expand it. So expand it again. So this implies 2 minus lambda. So this is negative, this is negative. So lambda square plus 3 lambda minus 4 plus 2 into minus 2 lambda minus 2 lambda plus 2 minus 2 lambda plus 2 1 into 4 minus lambda minus 3 equals to 0. 4 minus lambda. So this is 2 into 2, 4. This plus. So minus lambda plus 3. So expand it. 2 lambda square plus 6 lambda minus 8 minus lambda cube minus 3 lambda square plus 4 lambda minus 4 lambda plus 4 plus 4 minus lambda minus 3 equals to 0. So minus lambda cube, only 1 lambda cube. So 4 lambda cancel out. Lambda square, 2 lambda square, this is minus lambda square. So lambda square. So 6 lambda, this is minus lambda. So 5 lambda. 6 lambda minus lambda. 5 lambda. Now minus 8. Minus 8. Minus 8 and this is plus 8. Cancel out. Minus 3 equals to 0. 8 minus 8. So only this. So finally lambda square, lambda cube plus lambda square minus 5 lambda plus 3 equals to 0. So 1, 2 plus 3, 5. So lambda equals to 1 satisfies it. So 1 value is lambda equals to 1. So we factorize it. So lambda equals to 1 satisfies it. So lambda square into lambda minus 1. So we are getting lambda cube minus lambda square. But this is plus lambda square. So 2 lambda into lambda minus 1. So 2 lambda square minus 2 lambda minus 3 into lambda minus 1. So if we factorize, we get lambda square, 2 lambda minus 3. So again we factorize, lambda square, 3 lambda square, 3 lambda square. So lambda, 2 lambda square, this is minus lambda square, plus lambda square, this is minus 4 lambda. So lambda minus 1, so lambda cube, so minus lambda square, so this is plus lambda square, so 2 lambda minus 1, so 2 lambda square, so 2 lambda square, so minus 2 lambda, and this is 5 lambda, so minus 3 lambda, so 5 lambda, and this is plus 3, okay, so lambda square plus 2 lambda minus 3. Now if we put lambda equals to 1, then it is again 1. So lambda square plus 3 lambda minus 3 equals to 0. So lambda minus 1, lambda plus 3 into lambda minus 1 equals to 0. So lambda minus 1 whole square into lambda plus 3 equals to 0. So lambda equals to 1 and minus 3. So very simple problem, but lengthy calculation. So has non-trivial solution. So determinant equals to 0. We are getting how many values of lambda? That is 2 values. One is 1 and one is minus 3. So containing 2 elements. Containing 2 elements. So through this video today I have discussed consistency and inconsistency of linear simultaneous equation using matrix method and using determinant method. So I will take one more class to complete this section. So thank you for today.